Let an be a sequence of positive real numbers. The series an converges if the series means 4 options we have, and in 4 options 4 series is given to us. Convergence of these 4 series implies the convergence of series an. Means we have to check if option A is true, then series an convergent. Consider summation 1 upon n square. This converges by p-test, but summation 1 upon n doesn't. We, we all are familiar. This is not convergent. You can approach this by either definition or Cauchy nth test. So option A is not the right choice. Now come to option B. Is option B says summation an upon 2n square converges. Means limit of an upon 2 raised to the power n will be 0. It is clearly understood. Now this converges implies imply or not convergence of n. Now consider this is as summation 1 upon 2 raised to the power n. Now this is convergent because of geometric progression with common ratio half less than 1. So it is convergent, but series this not because of an equal to 1, and this is not convergent. Or you can consider an as n and apply nth root test or Cauchy nth root test as n upon 2 raised to the power n. Its root, if we apply root test here, then limit of n upon 2 raised to the power n and its nth root will be less than 1 if convergent, and it is given that this is convergent, then this one will be 1 upon 2 raised to the power 2 and it is less than 1, but this one not convergent. So option B discard here. Now come to option C and D. We know that if an plus 1 upon an converges, then limit of an plus 1 divided by an equal to 0, or limit an plus 1 divided by an less than 1. We can say less than 1 because if this limit is 0, it means limit is going to be 0 for sufficient large n. For sufficient large n. And this is the condition by ratio test. This is a condition. If any series is convergent, then this condition should be fulfilled. Means if this we have, then we can say this one is true. Means this series is convergent. So option C is nothing but ratio test. Now if C is true, then D automatically discard. We have ratio test in two format, or we normally write into types. If we see limit n tends to infinity un upon un plus 1, then this limit should be greater than 0 for convergence. If we see limit un plus 1 means n plus 1 in above or numerator and un in denominator, then this should be less than 1 for convergence. Otherwise we have divergent. So option C is true here. Means if this converges, then series this one also.